The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
This talk today is going to be specifically towards structural engineers. Okay, I'm going to be talking directly to the engineers. There's a little bit in here for manufacturers, a little bit in here for some contractors, any architects. It's what your engineers should know. So let's move on. I'm assuming that you know the 318 code, primarily the 318.11. So what I'm going to be talking about is the 318 versus 562. So the purpose of this talk, the similarities between the two, again, assuming that you already know 318.11, the differences between the two, because there are many differences, and new concepts. And that's an important piece, because there's a lot of new concepts for design. I say pick up the handbook. In this case, I'm going to go through a lot of the actual words of the code. So you may want to go to the web, and you can pick up all of the slides directly from the web. You don't have to make notes on exactly what's written in the code. So let's get started through it. The presentation goals that I'm having, again, the concepts is this presentation. Design examples, I'm not going to be talking about examples. So that's another seminar. That's the ACI all-day seminars, and there'll be some notes on using a guideline for using the 562. So that'll be your design examples. I'll talk a little bit about formulas today, but not really design examples. This is going to be the format. On the left, I'm going to be showing 562. On the right, I'll show 318. All right, so let's get started. 7.1. By the way, this is Chapter 7, of course. All right. Repaired structures, structural members, and connections shall be designed to have design strengths at all sections at least equal to the required strengths calculated for factored loads and forces in such combinations as stipulated in this code. Okay, that's nothing new. You already know that. That's virtually identical to Section 9.1 of the 318. There's a little bit of differences in the way it's written, but it's essentially the same. You guys already know that. Of course, design strength has to be greater than required strength. No great deal here. No great shakes. This is a bit of common sense, and I'm also going to use that word common sense more often, because all this repair design really is, it's a lot of common sense, and you'll understand why I say that. So let's go through. Strength and serviceability. Repaired members shall be designed to have adequate stiffness and limit deflections, vibrations, cracking, or any deformations that adversely affect strength or serviceability of a structure. That's really nothing new. Okay, it's common sense, but it's already noted in 9.5.1. Now, it's a little bit different. It does say adequate stiffness is to limit deflections. We talk about vibrations and cracking. So there's a little bit of nuances there. Similar, not quite exactly the same. 7.2.2. Repair design and construction procedures shall consider the loading, internal forces, and deformations in both the existing and repaired structure during the repair process. It's, again, a little bit of common sense. During that repair process. We'll talk about that a little bit more in a second. All right. 10.2.1 is almost the same, especially down here on satisfaction of applicable conditions of equilibrium and compatibility of strain. So we're really saying the same thing, just written in a little bit different terms. Now the behavior of repaired structures. Repairs incorporating new members shall be designed to integrate the new members with the existing structure, creating a structure capable, a structural system, capable of sharing and transferring the loads. It's not directly addressed in 318, but it's common sense. It just makes sense that you've got to incorporate new members, and you have to share and transfer your loads. 10.2.1, what I said a moment ago on satisfaction of applicable condition of equilibrium and compatibility of strains, sort of the same thing. 7.3.1.1, the design of the repair system shall consider the structural interaction between the existing structure and new members. The effect of the new members on the existing structure shall be evaluated according to the design basis code. Design basis code is already predefined. We're now in the design piece, so you should already know your design basis code. Not addressed in 318. So you got to know what your design basis code is by the time you get to your design. Again, common sense, the section really talks about or addresses changing the load path in an existing building. You have to think about that. That's common sense. Repairs to existing members shall account for force transfer at the interface between the existing member and the repair material or repair system. Now here it's permissible to use ACI 318.11 provisions in the design of the force transfer between new and existing concrete. What's that mean? You've got shear friction. We have horizontal shear. We have FRP, which is provided in 440R. We'll talk about that in a little while. And composite structure with the AISC. Okay? So it's a new concept, but it's really, again, that common sense in design. 7.3.2.1, structural repairs shall maintain composite behavior under service loads. Repairs shall be designed for the material and the existing substrate to perform as a composite section at service loads. You got to remain composite. We'll talk about bond in a second. But it's telling us that we have to maintain composite in our design. It's not really addressed in 318, except it does say composite for flexural members. We do talk about the same thing in 318. So it's not really a new concept. It's an existing concept. Bond. This is probably the most controversial and most talked about subject in the entire code. We've had more discussions on bond than any single thing. Think about it this way. New construction. What do you have about new construction? You have concrete and you take cylinders. So you know your concrete strength. What do we have in repair? We're bonding two materials together. You have to know your bond. We have to be able to test and know how the two materials bond together. It's a very easy concept, but what does it mean? Okay, here we go. The required bond strength shall be at least 1.5 times greater than the calculated bond force at the repair material to existing concrete interface. Okay, it's an important concept. We have to have at least 1.5 times more than what we need. How do you do that? Well, in a flexural member, that's your horizontal shear strength. Remember Moore's circle? Okay? Your horizontal shear stress is the same as your vertical shear stress. Okay, so that's the bond pull-off. It's also VQ over IT. Now, I'm only talking horizontal shear stress on a flexural member. There could be other forces there also. For instance, there could be tension forces. Could be peeling forces. So you got to think about those too. But in a flexural member, the horizontal shear stress is VQ over IT, and it has to be less than 1.5 times your bond stress. And that's your direct pull-off test. Okay? This is what's written directly in the code. There's other tensions that stress, like I said, that needs to be added to it, such as peeling forces or if you're in your direct tension. The next edition is going to have trigger points for mandatory testing. If you read the code directly right now, it says you've got to test everything. Well, okay, maybe we don't need to test everything, but it does require mandatory testing. The next code will have certain levels. The measured bond strength shall not be less than the lower of the required bond or the tensile strength of existing concrete. Well, of course, that makes sense. It's also not addressed in 318. So your bond stress, your bond capacity can't be greater than the capacity of the concrete. And here's what I just said a moment ago. Testing to measure bond strength of repair materials to existing concrete and the tensile strength of the existing concrete shall be tested in accordance with ASTM C1583. That's your direct pull-off test. So here's the test. Horizontal VQ over IT has to be the same as the vertical by Mohs circle. There are some other guidelines on it. ICRI has a guideline, and ACI 503R. Again, not addressed in 318. It shall be permitted to provide supplementary reinforcement. So what happens if you can't have that capacity, if you can't get there? Okay, you can add bar. And 11.6 tells you how to do that with supplementary reinforcement. Okay, so everybody have bond down really quickly now? It's an important concept that we have really never discussed before. It's brand new. More on bond. The licensed design professional shall verify the concrete substrate has adequate strength to sustain and transfer design forces of externally attached reinforcement. All right. That's a little bit new, but that's really Appendix D. So if you want some guidance on doing that, that's really the same in Appendix D. Permitted, yes. Permitted. You're allowed to do it. If you can't meet your bond capacity, you can add supplementary reinforcement. That's dowels. You can add dowels, you can add bars, you can add pins. This code does not provide, it does not work like 318 works. 318, of course, gives you the formula. This gives you the performance and the requirement. Adhesives. Adhesives used to bond existing concrete, repair materials, and repair reinforcement shall transfer the required forces between the elements. Okay, that makes sense. That's just common sense. All right, not addressed in 318, but like I say, that's common sense. The selection of adhesives used in repair shall consider the load type and duration and the effect exposure conditions on the adhesive properties. Got to think about fire, okay, elevated temperatures. Not addressed, but that is in Appendix D. A little bit for adhesives. Now, going on to the materials. The licensed design professional shall consider the properties of repair materials and systems in designing repairs and specifying repair materials and repair procedures. Here's where manufacturers come in. We've got to know what we're talking about. We need to know the properties of the materials. So the licensed design professional has to consider. This is an interesting word. Has to consider. Okay, it doesn't tell you exactly how to consider it. All right. There are several places within the code where it tells you have to consider. Not addressed directly, but in the 562 commentary, it tells you all the places you go for your consideration. Okay, and give you some help in figuring out how you do that. Now I'm going to go through some totally new concepts. So I'm not even throwing 318 on the right side. Materials already in use in a structure shall be permitted to remain in use where such materials conform to the design basis code. So whatever your rebar is, whatever your concrete is, if they're performing, you can use them. Materials conforming to ACI 318.11 or permitted by this code shall be used in repairs and alterations. Again, that's common sense. Alternate materials shall be permitted according to the licensed design professional's approval and in accordance with 1.4. Manufacturers, if you have this brand new material, you have a way to get it into use. We say we can do it as long as you get the engineer's approval or licensed design professional's approval, and 1.4 goes into telling you how you can do that. Design and detailing considerations, also entirely new, not addressed by 318 at all. Repair design shall be based on the member conditions identified in Chapter 6. Okay, so we evaluate, as Chuck had said, and now we can design to those properties we got in Chapter 6. The concrete, the in-place properties of the existing concrete, as identified in Chapter 6, shall be used in the repair design. Remember Chuck's example? That's exactly what he did when he designed his FRP. He was using the exact materials that he had analyzed or evaluated. Reinforcement that is damaged or corroded shall be permitted to remain. I didn't write the rest of it. That's an important concept. When we deal with corrosion-damaged concrete or spalls, if the bar has reduced area, you may use it. Just you have to take into account it's reduced area. But it may remain. You do not have to remove it and replace it. At locations where deformations are no longer present, which is a very common scenario, reinforcing bars shall be considered as smooth bars. So when you're doing your development length and making sure that your bars are embedded, you can just consider it as a smooth bar. And both existing and new reinforcement shall be adequately developed. It's taking into account when you have a spall, you've lost your development length. So now you have to take that into account and make sure your bars are developed. Brand new topic, but totally common sense. It just makes sense to be doing this. Pre-stressed. The effects of existing pre-stressing shall be included in the repair design. Remember, we're, of course, allowing pre-stressing to be used. So you have to include the existing pre-stress. The effect of modifications to the existing structural geometry, existing damage conditions, pre-stressing force release, and construction sequence shall be included in the repair design. Now, that is a new concept, but we're really following engineering logic. So you have to take into account your existing conditions. Stresses in remaining section after removal, after the concrete removal, shall not exceed the limits established in your design basis code. Think of a spall in pre-stressed concrete. You're taking out concrete. You've now increased your forces in your existing concrete. You have to take that into account. So you have to know your existing conditions, your existing properties and your existing conditions. Anchoring to concrete. Post-installed anchors and dowels shall be designed to transfer design forces to the substrate, considering anchor failure modes and the condition of the substrate into which the anchor is installed. The design of the post-installed anchor shall be in accordance with 31811. So we're just saying use Chapter D, or Appendix D, sorry. Okay? Repair geometry. Configuration of repair shall consider the potential for stress concentrations and cracking in both the existing structure and the repair area. Now that's a statement that makes sense. That's going to take a little experience sometimes. You have some re-entry cracking. You have different members that might have pre-stressing forces. This is a thought process. This really takes some engineering judgment and some good evaluation techniques in this section of the code. Repair using supplemental post-tensioning. Entirely new. But again, a section that has perfect logic to it. Okay, supplemental post-tensioning shall be permitted for the repair and rehabilitation of structures. Okay, you can design using external post-tensioning. Stresses due to supplemental post-tensioning shall be combined with the existing stresses, and the total shall not exceed the limits in the design basis code. Yeah, it makes sense. So if you add PT to an existing PT, add the two together. Essentially, what we're saying is use the 318 for the design of supplemental post-tensioning. It's just that you've now added post-tensioning to existing post-tensioning or pre-stressing. Repair using fiber reinforcing, FRP. Fiber reinforced polymer in conformance with ACI 440.6 shall be permitted to repair existing concrete structures. We now have a code that says you can use FRP. It's a great statement for those of us that design with it. If you have ever had an argument with a building official or with an owner, there's nothing that says you can. Now you can. Okay? The 318 commentary simply had said there was a guide. Now we're saying 440 exists and 440 is real, and you can design using 440. Structural members repaired or modified with externally applied FRP composites shall have adequate unrepaired strength as defined in 5.5. Okay, we have there was a question asked, I believe, to Chuck in his design when he evaluated the structure and added FRP to his inverted T-beam, and he said he did it in Chapter 5.5.1, that's what he used. Okay, so you have to have adequate strength if the FRP fails during the fire. Not addressed in 318 at all. 440 talks about it, but 318 does not. Okay. 791. Design of the repair system shall consider elevated temperature performance and shall comply with fire resistance ratings of the structural members and other safety requirements in accordance with the General Building Code. Currently, the only thing you talk about is adding cover over your rebar for fire protection. Okay, but now you have the ability to think about your fire protection. Of course, you have the 551 formula, but you have to talk about fire protection. It shall be permitted to design a repair without supplemental fire protection if the unrepaired member has adequate strength in 5.5. Okay, again, that formula. Okay? So that gives you another piece of ability if you can't, or another ability if you cannot meet your fire resistance rating. Again, that's not addressed at all in 318. A new concept. The properties of the specified repair materials at elevated temperatures shall be considered. Here's again that considered. Okay, so for manufacturers of products and materials using FRP, we need to know those properties. If somebody has this brand new material that can take elevated temperatures, we need to know that as designers. But you have to consider your elevated temperature. Elevated temperature may not necessarily be a fire. It may be in a boiler room, or maybe in a hot area in a plant in the industrial world. So you have to consider what happens during your elevated temperatures. Repairs using adhesives shall consider their performance at elevated temperatures. It's just directly addressing adhesives. It's really saying the same thing. Supplemental fire protection to improve the fire rating of the repair systems shall be permitted. So if you can figure out a brand new system that can give us better fire protection on materials that can't take fire, here we go. So if you can do that, you're permitted to do it. If you can design it and you can manufacture it, it's permitted. Fire rating of repaired systems based on ACI 216.1 shall be permitted. 318 has a reference to it, but not a requirement. So you're now permitted to use 216.1 in your design of fire rating. So let me finish with this. That's all the sections of Chapter 7. Let me finish with this statement. The repairs design really is straightforward. It's simply the design basis code plus engineering logic. Everything that I've said, all the new concepts have simply been common sense. I've been designing repairs for more than 40 years. In the days when I started, there was nothing. The only thing we had was engineering logic. So going forward, putting engineering logic with design basis code, we can have successful designs. Thank you.